Hi, I'm Shruti Roy, a master's student in data science at University of San Francisco. And today I'll be talking about my project, Hotel Booking Cancellation Prediction. Let me start off with a story about Erica. Erica is a hotel business owner and she just got a booking. She immediately gets to work to prepare for the customer's arrival. But as the booking date approaches, the customer cancels. Erica is distressed. And just like Erica, a lot of hotels feel the same distress over customers canceling at last moment. These cancellations lead to loss of income, lower revenue per room, mismanagement of the services that were prepared for that customer, and unpredictable occupancy rate. Now, what could be the solution of this problem? What if we are able to predict based on certain attributes of a booking whether a customer will cancel or not? That is what my project explores. For this project, I used an open data set that was found in a research paper that I linked down below. These are the most notable features that are found in that data. So what did we find when we looked at the features? The first thing that we notice off the bat is that it's an imbalanced data set. And this is something very important to note before creating models. Then when we look further into the features, since the data is imbalanced, it is a little hard to get conclusions from these graphs. But if you notice closely, for example, between July and August, even though the bookings are fairly the same, the cancellation is observed to be more in August. Further, in graphs like this, you can notice that as the lead time increases, the cancellation actually increases significantly, which is an interesting thing to note. Now coming to the most fun part of the project, which is modeling. I linked this notebook down below. The first thing that you do is feature engineering. I have one hot encoded all the categorical columns, and all the continuous column I have scaled using quantile transformer. All the missing values are taken care of using simple imputer, which imputes it with the most frequent values. I have created a custom evaluation metric for my grid search and cross validation, which is weighted F1 score because my data is imbalanced and this will take care of it. I've also created weighted recall score just to test the validation. There are three models that I have tried. The first is random forest. After hyperparameter tuning and cross-validation, the best score that I could get was 0.844. Then I used regularized logistic regression. Regularized because we have around 32 features and it will help with that. After cross-validation and grid search, the best score that I got was 0.82. Then I have used XGBoost, which combines the goodness of tree models and gradient boosting. The best score that I got with XGBoost was 0.8766, which is a really good score, and hence XGBoost was the winning model that we used for our test data set. Something that is also very important beside prediction is interpretation of the model. I have used permutation importance to find which variable was the most important in modeling our data. What I found was the country of origin, the lead time, and deposit type were the three most important variables while modeling the data, which is intuitive because, as we saw earlier, higher the lead time, the more is the propensity of a booking getting cancelled. Finally, we did prediction and we evaluated the model performance. We got a weighted F1 score of 0.8866, which is really good. And we plotted the confusion matrix. We got true negatives of 17,000 out of 18,000 and 9.3K out of 10,000, which is a really good score. It is around 91% and 85% respectively. So, what is the thing that we learned at this after this project? That tree models are generally really good when you have high number of features. XGBoost is something that combines the goodness of regularized models and trees and hence gives really good results. We saw this in our case as well. What we saw was it is possible to predict whether a booking will be cancelled or not based on selected features. We found out the most important features were country and the whether the person has paid deposit or not and what was lead time. Now, how can this model be used? The model was useful in highlighting whether a booking is going to be cancelled or not. The hotels can use this by taxing a customer beforehand with, so that he doesn't cancel it, or maybe even incentivizing the customer so that he doesn't cancel it. As the next steps for this project, we should productionize this model so that it stays up to date with the streaming data. That's all I had for this project. I hope you liked listening to it as much as I loved working on it. Please feel free to reach out to me for questions. Thank you.